Okay, this is part 2 of lesson 7.5, and in this lesson we're going to look at 2 more application questions. First one, 2 triangle question, looking at area, and the second one we're going to look at a 2 triangle question, but a 3D 2 triangle question. Let's start with our first one. A group of students are on their outdoor education trip. They leave their campsite and travel 240 meters before reaching their first orienteering point. They turn, creating a 42-degree angle with their previous path and travel another 180 meters to get to the second checkpoint. They turn again and travel the shortest possible path back to their campsite. What area of the woods did their triangular route cover? All right, so here we have campsite, first checkpoint, second checkpoint, and back to the campsite. Now, it wants to know the area of the woods that we covered, and if we remember how to find the area of a triangle, it is base times height divided by 2. And if you didn't know that fact and you were writing a test, it would be provided for you. But that's one of the very common equations that just becomes a part of your math repertoire eventually. But if it doesn't, ask and I'll provide it to you. Area equals base times height divided by 2. Do we know these two things? Because if we do, the question's really easy. Base is the base of a triangle, so we got 240, we know the base. We do not know the height, so we need to find the height. How are we going to do that? Well, let's look at our triangles. We've got a triangle on the left here that, since this is a 90-degree angle, so is this. We have a right angle triangle, and in this right angle triangle we have an angle. We need to find a side, and we have another side. Perfect. We don't know this side, because the entire length is 240 and we don't know which part that side is. It looks like this is bigger than this, so we're not going to split it equally, and we can't just guess how it's split. We'd have to actually calculate to figure out what side or what length this is and what length this is. So we're not going to do that. What we're going to do is just work with this left side triangle to find the height, and we should be able to do that. So ignoring the triangle on the right, let's just look at the triangle on the left. We have an angle, so we can label our triangle from that angle. From 42 degrees, we can look across, and we would get an opposite side. If we look across from the 90, we get a hypotenuse. And the side that's between the angle we know and our 90 is our adjacent side. So what do we know and what do we want to find? Well, we know the height. We know the hypotenuse, not the height. We want to find the opposite, the height. So we can check with SOHCAHTOA. Which equation are we going to use? Which one has H and O in it? That is SO. So we're going to write the sine equation. Sine theta equals opposite over hypotenuse. And we'll have to come back to our area equation. So what do we know? We know the angle. So we got sine 42. Opposite is height. Hypotenuse is 180. And now we just have to solve this sine equation. Fortunately, the side we want is on top, so we just have to multiply by 180. Bring the 180 up and multiply. We get 180 times sine 42 will be our height. And using a calculator, 180 times sine 42 is 120.44. We'll just round that to 120. Now we have the height, which is important. And we have the base, which is 240. Now we can use our area equation. So what is this question? Well, it's a lot of stuff all at once, and it's kind of trying to manage what you're given, looking for what we need to solve for what we actually want. In this case, what we want is the area. We need the height to find the area because we already have the base. Now we have both. We can find it. 240 is the base times 120 is the height divided by 2. we've got 240 times 120 divided by 2. 14,400, and we're working in meters. And area is units squared. So now we can write a conclusion. Therefore, the area covered by the root is 14,400 meters squared. All right, one last question. We've got a 3D problem. A theodolite is an instrument used by a surveyor to measure horizontal and vertical angles. Measurements are taken in order to find the height of a cliff on the other side of a river, as shown. Find the height of the cliff to the nearest meter. So what we have here is we have two triangles. We have a triangle about the river, so from two different points on the side of the river, we know the angle to get to the hill, the cliff. And then across the river, we know the angle to get to the top of the hill, cliff. What we want is we want the height. We want to find that height. So if we ignore this triangle and we look at the triangle that's a right angle triangle but the height, we'll notice we have an angle, but we don't know any side. We don't know this side. So we can't just solve for the height directly. We have to use this triangle to get some information about our other triangle. When you have a two-triangle word problem like this, the key is usually to find an angle or a side that's shared between the two triangles. And in this case, the side that's shared between the two triangles is this side right here, across from angle y. Let's call that side y. If we can find this side, then we'll have an angle and a side to find our height. So the key to the question is figuring out this side. This side is also in a right angle triangle with our 90 degree here. I'm going to redraw this first triangle so we can see it. First triangle. So I'm going to draw it like this with a nice right angle. So this is our x with our right angle. This is our c. This is our y. We know this angle is 52. And this is our side y. Oh, and we've got 75 right here. So there we go. We're going to first work in our first triangle in order to find side y. So we can use our second triangle to find our height. So let's solve for side y in our first triangle. Well, what do we know? We know an angle. So let's label it. Across from our angle is side O opposite. Across from the 90 is our hypotenuse. And the side between the 90 and the angle is our adjacent. What do we have? Well, we have the adjacent side. We want to find side y because that's the side connecting both triangles. O and A, if we look at SOHCAHTOA, that's TOA. So we're going to use tan. So we're going to write a tan equation. Tan theta equals O over A. And let's fill in what we know. We know the angle is 52. The opposite side is our side y, and the adjacent side is 75. So if we solve for side y, we'll have that shared side. Y is on the top, so we're going to multiply across. And we've got 75 tan 52 equals y. And now we can use our calculator. 75 tan 52, 95.99. Since we're going to round our cliff to the nearest meter, let's just go with 96. So now we know our shared side y. How come that's important? Well, now that we know what side y is, we have this side of the triangle. So now I'm going to draw my second triangle. You don't have to redraw the triangles, but for this, if I redraw it, it might help, and it might not, but if it does help, then maybe it's something that you want to try. We got a 90-degree triangle. We're drawing this triangle. XFC. Between F and C is our height. That's what we want to find. We know angle X is 61 degrees, and we just found out that Y was 96. That was our Y. So now that we want to find height, we just need to label the triangle with opposite, adjacent, hypotenuse, and find out whether we're going to use sine, cos, or tan to solve for height, because now we have an angle on the side. So across from our angle is opposite. Across from the 90 is hypotenuse. And the last side is our adjacent side. So what do we have? Well, we want O and we have A, so we have another TOA. So we're going to just do the tan equation again. So we've got tan theta equals O over A. Now our theta is 61, so we got tan 61. Our opposite is the height we're looking for, and our adjacent is 96. It's even the same solve step. Bring the 96 over and multiply, and that'll give us our height. 96 tan 61. So let's do some math. 96 tan 61 is 173.2, rounded to the nearest meter, 173. Oh. So now we can say, therefore, the cliff is 173 meters tall. And there we go. We just solved a double triangle question. Looking for area was our first example, and our second example, double triangle question in 3D, looking for the height of a cliff. So what do we take from this? Well, what we take is, if we're solving for sides and angles in a double triangle question, you're probably looking for that shared side or angle first, and you're using the triangle that has the most information. The most information is either a side and an angle that we know, other than the 90, or two sides. Once you've found that shared side or angle, you can use it to find other sides or angles in the other triangle. Okay, that's it for lesson 7.5, part 2. I will see you next time for lesson 8.1, where we look at something new called the sine law. Thanks for watching.